Hi students, in this video I am going to discuss solid state number of particles calculation in simple unit cell, BCC, FCC, edge center. After that I am going to upload FCC packing efficiency, BCC packing efficiency. Already I have uploaded packing efficiency simple unit cell. Next Next two videos, FCC, BCC packing efficiency. Okay, let's begin with first number of particles calculation. Number of atoms in unit cell or number of particles. Number of particles. Students, particles is nothing but it may be atoms, it may be ions, it may be molecules. If you are calculating in covalent crystals, atoms, right? What is ionic crystals? It's ions. We consider as ions. In molecules, like molecular crystals, molecules. Like particles is nothing but it can be anything. Okay, now I am going to discuss number of atoms in particles in unit cell. So first one, I am going to discuss simple unit cell. Simple unit cell, also call it as primitive, right? So in previous video, I have given explanation what is primitive unit cell. Primitive unit cell is nothing but particles occupied only at corners. What is that, students? Particles occupied only at corners. Already I had given detailed explanation. Please go through that part 1 and part 2 and then come back to the part 3. Okay. So this is unit cell, students, smallest portion in a crystal lattice I am taking. Okay. So here particles. I am writing particles. This is the corner. Here, 3, 4. For this cube, 4. And this one, 5, 6, 7, 8. Right? So only particles at corners. Those we call it as simple unit cell or primitive unit cell. Okay. Now here, how many corners, students? Yes, 8 corners. Number of corners, 8. Number of corners equal to 8. And another point, each corner sharing or sharing 8 unit cells. 8 unit cells. See, if you look into this one like just a room corner point you can imagine, students. Vertical line, so like this, vertical line, horizontal line, vertical line, and then this is a front view, back view, three-dimensional space, no, top and bottom, and same like upper one also, same 8 corners, totally 8 unit cells, 8 it is connecting, 8 points it is connecting. Simply you can remember here, each corner, so listen students, each corner contributed by 8 unit cells. 8 unit cells. Each corner, each particle is contributed by 8 unit cells. 1, here 2, here 3, here 4. Like bottom 4, top 4. Like that you can imagine. Easily you can understand. So now we will calculate the number of particles. Students, see. Number of corners 8. But each particle sharing 8 unit cells. Here 4, top 4. Totally 8 unit cells. Okay. 8 into 1 by 8. So 8 gets cancelled, finally 1. So here number of particles in simple unit cell, totally number of particles is nothing but number of atoms in simple unit cell equal to 1. That is represented by the letter 1. Clear? Okay. Now, here calculation number of atoms in each unit cell plays important role, while packing efficiency time we are using, even density numerical time also, it plays important role. Okay, students. Now come back to the next one. BCC. So BCC is nothing but body cubic center. Body cubic center unit cell. Okay. So all unit cell, first it satisfy the primitive. So previous video you can watch it. What is primitive unit cell center? Also whether it is primitive or not, first it is satisfying primitive or not. If you want clear explanation, you go through that. I am explaining here further points. See here. All center, any center, FCC, BCC, edge center, whatever it may be, first it can satisfy primitive, means corners, particles present at each corner, again same like above case, right? 1, 2, 3, 4, 5, 6, 7, 8, 8. Here same story. So number of corners, how many students? Number of corners equal to 8. Each particle at corner, particle is nothing but it may be atom or ion molecule. I said no, atom. Each particle sharing, each particle contribution or sharing how many unit cells, students? 8 unit cells, right? So that's the reason how we are taking this one. Same like above case. Why? Because first it is like a primitive, no? Primitive we have to calculate. 8 into 1 by 8. Each particle sharing 8 unit cells. 8 into 1 by 8, 1. We have to write points like this. Next one, body. You look into this, students. Look into this. Here, this cube, it has only one body. Center, only one body. That's it. That you can write here. So body center, 1. Okay. That is finally how many particles, students? Body center atom you can write. So totally 2 particles. Finally, Z equal to 2 in case of BCC, right? Now going for the next calculation, that is FCC. Phase cubic center unit cell. Phase cubic center unit cell, FCC. Phase cubic center unit cell. Okay, now look into this. Again, I am going to draw the diagram, that is unit cell. See, look into this. Cube. All centers, first it satisfy the primitive, no? Primitive means, again, corners. Particles at corners. Correct. 4, 5, 6, 7, 8. How many corners, students? Yes, 8 corners. Each corner contribution are sharing 1 by 8, right? So 8 into 1 by 8, that is equal to 1. This first part is common for all unit cells. Now next part, look into this. Phase centers. How many phases? I am drawing here structure, students. Listen. See, this is one phase, right? This is one phase. It has center, face center. This face has center, face center, right? Now look into this, right? This is also one face for the unit cell. It has center, face center, right? Now next one, same like that you can consider this one, right? This is face for this unit cell, it has center. Next, same thing. This one also you can observe. So finally here how many faces we have got? 4 faces. Is it final answer? No. 4 faces here. Next point, see where I am drawing the structure. See this cube. Look into this cube. This cube face. This is one face. This is face. For this face, center here. Face center. Next, this cube also. Consider even this cube. Right? This cube. That's it. For this one also, face center. That's it. Totally, how many faces we have got it? Number of faces equal to 6. Number of faces equal to 6. Each phase contribution, each phase contribution 1/2. How it is? Imagine this one. This is this wall, like even where you are sitting room also you can consider, students. The room wall you can consider. It will connect the 2 rooms, right? It will connect. This is another unit cell. It will come. That wall connected to the 2 rooms. One is maybe bedroom, one is hall, or else something. Definitely this wall is this space is this is sharing 2. So that is, suppose you are sitting in a common hall, that common hall one wall you can consider. The wall is connecting to the next room and this one. So each one sharing 1/2. Each contribution is 1/2. That's it. So 6 into 1/2, that is 3. Totally how many particles? 4. This is where? Which case? Yes, FCC. In FCC, finally what is our answer? Z equal to 4. Clear, students? Now, going to the next one. End center. End center are also called it as edge center. End center, edge center. This is rarely they are asking in examination, but we can look into this point also. Again, you going to draw the structure. What is that? Cubic unit cell. Okay. Now, yes. Right? First one is primitive. Particle, your corners, right? 4 corners, and your 4 corners, totally 8. Tell me, students, how many corners? Yes, 8 corners. Each corner contribution 1/8. 1/8. Now 8 into 1/8. Here again we will get 1. The first point completed. Now I am going to discuss end center or edge center. See, students, this is okay. This is my starting point. This is my end point. These 2 points I am considering. This is starting, end. So this is my target. So for this edge length, what is this edge center? Edge exactly center. You can write that one. See, this one, center. I better draw like this. Same like here. You can consider this one. This end, you can consider. Yes, you will get your center. Right? and this one, these two you can consider. Yes, you will get center. These two you can consider your end. Here to here end we are seeing, so measure we are seeing, so that we call it as edge length, your edge center exactly. And these two corners if you consider end center. These two corners if you consider here, and these two here, and these two center, and these two here, right? These two here, these two here. Totally, how many here also? Finally, you will get 12 edges, students. How many students? 12 edges. That only we can write here. Number of edges, 12. Each edge sharing 4. Each center, edge center sharing 4 unit cells. You can see where you are sitting room also. Just end you can consider, end the center. With the help of this one, we can construct the 4 rooms. Where you are sitting, that room and that bedroom, and other sides also too, it is possible. Other sides also too, it is possible. End you can consider, students, end. So like that room and where you are sitting, that next room, and what is this, where you are sitting, that room, and what is this, one bedroom, and next one, and outside also two. So that is finally you can remember easily. So each edge center share 4 unit cells. 4 unit cells. Okay. So 1 by 4. So 12, 3. Finally 1 plus 3, 4 particles. Z equal to 4. Clear, students? Clear? So you can imagine here itself if you are confusing. This room, okay, and here one more room. With the help of this one, we can construct the here. Like this, you can imagine. Okay. So finally, all number of particles, all the unit cells number of particles calculation is completed. Now I am giving conclusions here. What are the conclusions? Next, write down. Simple unit cell conclusion. Simple unit cell, number of particles equal to 1, Fcc Z equal to 4, and Bcc Z equal to 2, and edge center or end center. So what is this? Z equal to 4, right? Here these two 4 only, but different explanation, right? Now next one here, FCC, sometimes they are asking CCP. Why? Because packing efficiency, after completed the packing efficiency, will come to know out of all unit cells, FCC is more close packing. Simple unit cell, it occupied by 52.4% only. To understand this one, I am giving the points. Occupied one, 52.4. And FCC occupied by 74%. This is 68%. Compared to all, which is more close packing, out of 100%, 74% is packed, occupied. This is more close packing. That's why we call it as cubic close packing also, FCC, CCP. Okay, in numerical part, sometimes they are mentioning FCC, sometimes they are mentioning CCP. Okay, students, with this, what we have completed, number of particles calculation is completed. Now, next one I am going to do, what is that? FCC, packing efficiency. Okay. FCC. Phase cubic center, or else CCP. Cubic close packing. Okay, packing efficiency formula, and what is the simple unit cell packing efficiency already we have discussed. In this video I am going to give packing efficiency, in which case FCC. Okay, Now FCC, just now we have taken diagram, now students. Once again you can draw this one, unit cell. Okay. Now this is another cube, right? Okay. Number of particles we can write here. Corners. First of all, it is satisfying the primitive unit cell. No, 1, 2, 3, 4, right? And for this space, you can consider even a simple unit cell also. These four particles we have taken. No? These four particles we have taken like this. 1, 2 touches each other. 1, 2, and this 3, and this is 4, right? So simple unit cell we have drawn like this. Only four particles we have taken. Why? Because it is primitive only at corners. But in FCC, it has face, no? See, this is the face, right? At least one side you can calculate. In same side, all the sides same it will be. So here face, this is face center, right? Now I am going to draw here on paper. See what I am going to draw here. This particle, yes, and this particle and this particle. These three particles I am drawing here. Check it, students. Okay. So here this one, this one. These four particles we are writing along with this space center also we are taking. Space center also we are taking. Okay. Mm. See, in four particles are there, students. These four particles are there, like touches each other, and this is touching each other, and this is touching each other. And see, here one center is there, one center is there. That I have drawn here. That's it. For explanation, packing efficiency. Okay, now we can take the triangle here, like Pythagoras theorem. Pythagoras theorem. So here A, this is A, and consider as this is B, and consider as this is C. And length A, here we are taking, and here also we are taking A, even this edge length, okay, that we can calculate. Okay, students? According to Pythagoras theorem, we know, no? Pythagoras theorem. What is that formula? AC square equal to, yes, AC square how to calculate? Yes, AB square plus BC square, right students? Yes, what is AB square? Edge length A, no? A square plus BC square, again A square. That's it. Now you can write, students, AC square equal to, yes, simplify. AC square equal to 2A square, right? AC equal to root 2A, right? AC equal to root 2A, right? That's it. Now this is what equate to the radius. Edge length equal to A equal to R. A equal to 2R we have taken in simple unit cell, no? Here what we are taking you can see. So edge length A equal to, so what you will write here, see this is particle, no students, like I will draw here, this is particle, this is, okay, here to here, this is radius. For this one radius. What is atomic radius definition, students? Center of the nucleus to the outermost orbit. This is radius. And here this is center, right? Here to here radius. How much? R. And here to here again radius R. And here to here again radius R. Totally 4R. Totally 4R. That only you can take it up. Root 2A equal to how much, students? 4R. It's very important. It plays important role here. See, students, first one, okay, once completed explanation, I'll come back to the conclusions. Root 2A equal to 4R. Then what about A, students? A equal to 4 by root 2R. Okay. So we already calculated. What is this, students? Volume of unit cell. Okay. I'm calculating here volume of unit cell. In simple unit cell also we have calculated. What is that volume of unit cell? Yes, A cube. A cube, right? A, you know, you can substitute 4 by root 2r whole cube, right? So 4 into 4, 16. 16 into 4, yes, 64. 64. A equal to, so what is this? A cube. A cube we are doing, no? So this is 64 by, so what is this? R cube. Okay, fine. Next, root 2 whole cube. How we can simplify this one? Anyone have idea? Root 2 whole cube. How to write, students, root 2 whole cube? See, simplify. Root 2 whole cube means I am writing here. Root 2 whole cube. How to write? Root 2 whole square, root 2 power 1. Okay. Bases are same, powers are powers adding, we know no, this point. Then afterwards you can see this root 2 and square gets cancelled. Then finally what you will get here? 2 root 2. Right? 2 root 2. That only you can write here. 64 by, yes students, 64 by 2 root 2 r cube. If you will simplify here itself, then after substitution in the packing efficiency formula, it takes very less time. That's it. Okay, now next one. We all know what is the first point? Volume of the particle. What is the volume of the particle? That is sphere. It is spherical shape, no? Volume of the sphere. Or what is sphere here? Particle, atom we are considering, no? What is that? 4 by 3 pi r cube. That's it, students. Everything we know, just we can substitute in the formula. So what is the packing efficiency formula? What is the packing efficiency formula, students? Packing efficiency equal to, yes, packing efficiency or packing fraction, your wish. Packing efficiency equal to volume occupied by, right, volume occupied by, what is that point? 4 spheres. Volume occupied by 4 spheres in the unit cell, or else you can write like this also, Z into volume occupied, volume of the particle by total volume of the unit cell. Volume occupied in the unit cell, volume occupied in the unit cell by, what is this? Total volume of the unit cell. Total volume of the unit cell. Volume of the unit cell. So that is into 100. That's it, students. What is Z here? This is FCC, students. FCC already we have calculated Z equal to 4, right? You can substitute 4 into volume occupied by unit cell. How much, students? Just now we have calculated, no? 4 by 3 pi r cube. Volume of the sphere, right? Volume of the sphere. How much? 4/3 pi r cube. You can substitute here. That's it. By total volume of the unit cell. Total volume of the unit cell also A cube we have calculated, no? What is A cube simplification value? 64 by 2 root 2 into 100. Percentage we are showing, right, students? Can you simplify this one? See, r cube gets cancelled, right? Afterwards, 16. 16 pi by, what is this? Yes, 3 into 64. This 2 root 2, it will go up. 2 root 2, that's it, into 100. Right? Any cancellation terms is there, you can cancel, students. After that, try to simplify this one. Try to simplify this one. Yes. 16. How many times students here? Check it. How many times? Yes. 2 you can cancel, and this is 32 times, again 16. How many times? Yes, this is 2 times. Now any cancellation terms? Okay, 16 to 2 16s are 13 to 32. 32 32s are 64. Yes, correct now. Now remaining part you can write. Any other cancellation terms is there? No. As it is you can write. What is the left out here? 5 root 2 by, next tell me, 3 into 2. 3 into 2, 6 into 100, right? What is pi value, students? 22 by 7, you know, no? 3.14 into, what is root 2 value? What is root 2 value, students? Yes, 1.41 by 6 into 100. So can you simplify this one? Try to give answer. What is the packing efficiency now? Yes. Anyone got answer? Here you will get 0.7379 into 100. Into 100. So then how much occupied, students? Tell me. That's it. Into 100, no? 73.79. That is nearly equal to 74 percentage. See, this is occupied. You can write conclusion points. What are conclusions here? In Fcc, occupied occupied percentage equal to 74. 74 percentage. Unoccupied equal to how much, students? Tell me. 100 minus 74. Actually, what is our target, students? 100%, no? But out of 100%, how much occupied here? How much occupied? Only 74% occupied. What is the left out here? What is the left out? 26 percentage. Both they will ask in competitive examination. Okay. With this, we have completed Fcc. Okay. Now, next one, students. Every unit cell, simplification to be allowed, ma. Simplification, one small mistake is there. That's it. Definitely will get mistake. Final answer. But whenever you write in examination Fcc or any unit cell, main important points I am writing here. These points, main points we have to write on the paper. What is this? First one is diagram. Diagram must. We have to draw the diagram. Second point is A and R relations. Based on this, we have very good number of competitive questions. Coming days, I am going to upload. Okay, A-R relations. Next one, packing efficiency formula. And next one, simplification. So they will give marks. Like that, all points you have written or not, we have to check it. So direct questions you are getting, theory questions. NEET exam means occupied, unoccupied, how much percentage, even mains also sometimes they are asking. And next mains questions and NEET questions, once completed the chapter, I am going to upload previous year questions, students. Thank you. Thanks for watching, and please share and give likes also. Share to many people. Definitely all the people, they will get benefit in examination time. Okay, students. Thank you. Thanks for watching.